Welcome to Functions and Function Notation, and in this particular short video we're just going to worry about how do we find the value of a function. Just as a little reminder, remember we're going to stop and think about exactly what we're being asked to do. Then we're going to go through and actually do it out, and then double check to make sure I've answered the question that was asked originally. Let's take a look at our first example here. So this is given the function f of x is equal to x squared plus 3x minus 4. Evaluate for the following. So in this particular case, in the first one, it says take the value of the function, determine what it is, given that x is 2. So this is the nicer of the different types. So all we're going to do is go through and do the mathematics for this, where I'm going to substitute 2 into here. So I'm going to end up with 2 squared plus 3 times 2, oops, that's a 2, minus 4. Order of operations as I deal with my exponents first. So 2 times 2, 2 squared is going to be 4. Then I deal with multiplication. So 3 times 2, that's 6. And then I'm going to subtract 4. 4 plus 6 is 10. 10 minus 4 is going to give me 6. So the value of the function when x is 2 is going to be 6. That's it. That's all we're doing. So now if I substitute this one in, this is really easy because all I'm doing is just taking a, and everywhere that I see an x, I'm replacing it. So this is going to be a squared plus 3a minus 4, and I'm done. That's it. Here, though, we get a little bit more complex. I'm going to have to substitute these values in. I'm going to have to figure out what, in the places of x, I'm going to put a plus h. So I'm going to have in parentheses a plus h squared plus 3 times a plus h minus 4. A plus h squared. So by now we should know how to do squares without actually having to go through and say, all right, I'm going to take this times this, go ahead and FOIL. I should know I get a squared plus 2ah, it's an h, plus h squared. Here I'm going to distribute the 3, so plus 3a plus 3h, and then subtract 4. Let's look to see if we have any terms that we can put together, and there's actually nothing. So yes, we did all of that work, and we really got nowhere with it. It doesn't change anything. It's just that's what it is. It is what it is. All right, so now let's scroll down to this last one, and here I've got to take all the parts. So I'm going to go up here. I'm going to take all the information that I already know. So go back to the pen here so that I can write. All right, so now I'm going to go through, and we already know a plus h. So we've got all of this stuff plus 2ah plus h squared plus 3a plus 3h minus 4, and then oops, I'm going to subtract from that everything that I got for f of a. So I'm going to subtract a squared plus 3a minus 4, and I'm going to divide all of that by h. Yes, I know it's not a very straight line. So this is going to be a negative a squared. That's going to be a squared. Let me get a different color here so I can start crossing things out that are going to go away. So that's going away. That's going away. I have 3a minus 3a. Gone. Gone. Minus 4 minus negative 4. So remember, minus a negative is the same as plus. So that's gone, and that's gone. So the only stuff that I have left would be what has not been crossed out, and I've got then, let's see, I've got a 2ah, I've got an h squared, and I've got a plus 3h, and everything else is gone. So let's just, I'll write it like this for now, 2ah plus h squared plus 3h, all divided by h. Notice in the numerator, every single term has an h, so I should factor out an h. I'm going to scroll down and give myself a little bit more room here. So if I factor out an h from this in the numerator, I'm going to clean this up a little bit. All right, I'm going to put the order into something that's a little more reasonable. So if I factor out an h from here, I'm going to get an h. If I factor out an h from here, I'm going to get plus 2a. If I factor out an h from here, I get plus 3. All I did was just change the order to make it look a little nicer. It didn't really do anything. All of which is divided by h. Now, as long as h isn't 0, what's going to end up happening here again is that I'm going to get rid of this h, get rid of this h, and now I've simplified this down to a much cleaner looking expression than the one I had there, which now is h plus 2a plus 3. Double check, and again, you can pause this video at any time, but double check to make sure that you understand what happened to certain parts, where did this go, rewind, play it again if you're not quite sure. All right, so for this one, given the function g of m is equal to the square root of m minus 4, determine the following. All right, so we have a square root function, and we know that we're going to have issues because I can't have anything underneath be negative. So I'm just thinking that out loud at the moment, but we're going to wait to deal with that because that's not what I'm being asked to do here. But this is what I mean by the thought process. Think before you do. All right, so I can't have a negative underneath a radical because it doesn't work for me. All right, so now I'm going to go over to here and take wherever there's an m, I'm going to replace it with a 5. So I end up with the square root of 5 minus 4, which then I simplify what's underneath, square root of 1. Square root of 1 is 1. So again, g of 5 is equal to 1. In other words, the value of function g when m is 5 is equal to 1. Now let's figure out g of x. Well, all I do is, okay, well, here's m, and it says, hey, replace everybody with an x. Okay, that's easy enough. X minus 4. Done. Next one says solve for gm equaling 5. So I want to know, when is this thing going to equal 5? All right, so then that means I need the square root of m minus 4 has to equal 5. In order to get rid of a square root, I have to go through and actually square both sides. So I'm going to do that. We'll go through and we'll square both sides. So now I get m minus 4 is equal to 25. Add 4 to both sides. And then I'm going to end up with m equals 29. All right, so basically g of 29 is equal to 5. And we can double check this. Let's scroll back up to the top. If I put a 29 in here, 29 minus 4, that's 25. Square root of 25 is 5. Next one. Express a relationship of 2n plus 6p equals 12 as a function p equaling f of n, if possible. So I want to get p completely by itself. So in order for me to do that, to get p completely by itself, I'm going to have to subtract 2n from both sides. I get 6p is equal to negative 2n plus 12, because I can't combine these. Divide everybody by 6. So negative 2n plus 12, all of which is divided by 6. Let's clean this up. P is equal to, let's see, I've got to divide this by 6, and I have to divide this by 6. So I'm going to get negative 1/3 n, and again, because 6 divided by 2 is going to give me 3, 2 divided by 2 gives me 1. 12 divided by 6, that's just going to give me 2. So notice the wording here. It says to express this relationship that we started with as a function where p is equal to f of n. I'm not quite done yet because I haven't answered the question that they're asking for. So now f of n is equal to negative 1/3 n, whoops, plus 2. Okay, so I've gone through and I've answered what it says, changed it into this. Was it possible? Yes, we were able to go through and do all the arithmetic to get me there. That's not a problem. All right, well, a short one this time around. So thanks again. My name is Robert Main, and well, we'll talk to you on the next one. Thank you. Bye.